Hi friends, welcome to Basic Electrical YouTube channel. So in this lecture, we are going to solve problems on 3-phase induction motor, class number 6. It is part 2 problems. See in problems part 1, I already done 5 problems. Go through that problems. After that only watch this lecture. Okay. So in part 2, I will be doing around again 5 problems. Okay, that is from question number 6 to question number 10. See, we can start this. So an 8-pole alternator runs at 750 rpm. So again this question is alternator induction motor combination. So they given an alternator, how many number of poles it is having? 8-pole alternator. The alternator running, the speed of alternator is ns. So what its speed? 750 rpm. Alternator runs at this speed. And this alternator supplies power to a 4-pole induction motor. This alternator is supplying power to 4-pole induction motor. So number of poles is 4. And they given the frequency of the rotor is 1.5 Hertz. Rotor frequency is given as 1.5 Hertz. These are the data given. They are asking what is the speed of motor and what is the slip. You need to calculate the value of n and the value of slip. See what is required to calculate n? We need ns. Okay. If I know ns and slip, I can easily find n. Our first aim is to calculate what is synchronous speed of induction motor. So we can find out from the alternator data. See, alternator is giving only namesake. Okay. Only we need to take electrical quantity. Okay. Electrical output of alternator given to the input to induction motor. So what is that frequency of alternator electrical output? Same frequency for induction motor input. Let me calculate frequency from the available data. So frequency formula is PNS by 120. How many number of poles? 8 poles. What is the speed? 750 rpm divided by 120. So do it in calculator and tell the answer. What is the frequency you will get? Okay, very good. So you will get 50 Hertz. Excellent. So alternator going to produce electricity at a frequency of 50 Hertz. That electric supply I am giving to the induction motor. So you take same frequency for induction motor stator. So the frequency is 50 Hertz. Now with the help of this frequency and the poles, you calculate synchronous speed of induction motor. So ns of induction motor is 120 F by P. So 120 into, what is the number of poles? Very good, 4 poles. What is the frequency? 50 Hertz. Please calculate and tell the answer. How much you will get? 1500. Very good. Okay, 1500 rpm. So this is ns value, synchronous speed. Now, before finding n value, I am going to calculate slip. Why I am going to calculate slip? See, I know f value and I know fr. By knowing f and fr, we have a formula. Okay, slip is equal to, otherwise rotor frequency is slip times of supply frequency. So from this, slip is equal to fr by f. What is rotor frequency? 1.5. What is supply frequency or stator frequency? 50 Hertz. So guys, what is the answer? What is the slip value? 1.5 divided by 50. How much you will get? Very good. 0.03. So this is the value of slip. So I calculated slip. Next is what is speed of the rotor? Speed of the rotor. See, rotor speed formula is n is equal to ns within the bracket 1 minus slip. You must write here absolute slip. This is absolute slip. Don't write 3%. Don't write 3. 1 minus 3 you become negative. Rotor speed never become negative. Okay. See now, what is synchronous speed? of induction motor. Don't take the speed. Okay, don't take alternative data in induction motor formulas. Got it? So 1500 into 1 minus, what is the value of slip? 0.03. Please, 1 minus this, will get something multiplied by this. What is the answer you will get? 1455. Okay, fine. I am not sure about this. What you are telling, I am writing the same value here. Okay, 1455 RPM. So this is speed of induction motor. Okay, or the speed of the, see, they can ask what is speed of motor or what is speed of rotor. Both are same only. So correct answer is 1455 RPM. As you calculated, same thing I wrote here. Okay, if any mistake, please mention in the comment box. Okay, let me please copy down this. We can solve another problem. Okay, students, now we can solve another problem. So question number 7. See guys, this problem is very important from exam point of view. So what they are doing means, in this problem, they are going to miss some data. Okay, so even though we have to find solution, even though the data is not given in the problem, we have to find solution. There are other ways. So we can go into the problem. What is the data missing, we can notice later. So a 12 pole 3-phase alternator means there is an alternator having 12 poles. Okay, is coupled to an engine. Alternator is coupled to some mechanical input, and the alternator running at a speed ns is equal to, what is the speed? Very good, 500 rpm. So speed is 500 rpm. See, from this, later we can find frequency. That alternator, it supplies an induction motor. So this alternator will going to supply for an induction motor. Okay, induction motor which has a full load speed of 1440 rpm. The speed of induction motor is 1440 rpm, and they are asking what is the percentage slip. Okay, and number of poles. This is number, NUMBR, number of poles of the motor. So how many number of poles? So this is a question they asked. Means when induction motor connected to alternator, so the induction motor runs at this speed. Okay, so let me find what is the frequency. Induction motor requires electrical supply. So what is the frequency of this supply? That can be found out by alternator data. Okay, so what is the formula? F is equal to PNS by 120. Number of poles 12. Speed is 500 divided by 120. What is the answer? Sir, every time we are getting 50 only. You can write that only. Okay, 50 hertz. See, they can give data in such a way that you may get either 50 or 60. Need not to worry. But always solve it and write the answer. Don't stick on directly 50 hertz. Okay, that is not correct. Stick on this formula. What data they give, you can enter it here. What frequency? You may get 33.33 also, 50.5 also, 49.5 also. But they are giving standard data, so we are getting standard frequency. See now, take this frequency. The alternator produces electrical supply at this frequency. Same supply I am giving to induction motor. So induction motor frequency will be what? Induction motor stator frequency is 50 hertz. See, now to calculate percentage slip, what data is required? We need FR or F. If by knowing rotor frequency and supply frequency, I can find slip. Another is slip formula. S is equal to Ns minus N by Ns. For that, what I required to find Ns. To find Ns, let me find Ns for this. So, what is induction motor Ns formula? Ns is equal to 120F by P. See, supply frequency is given. How much? 50 hertz. I can take this frequency here, but poles, because poles itself asked in the question, what is the number of poles? See, induction motor poles, it can be any number, but they are not given. We have to identify. So that is the data missing here. Okay, that data itself we need to calculate. Okay, how to solve? See, we can assume the poles of induction motor. We have done similar problem in part 1, assuming frequency either 50 or 60 hertz. Then we checked the slip condition, speed condition, like that. Okay, in the same way we can also do it in this problem. See, look at here. So keeping in mind, the poles should be always even number. There is no odd number poles. The number of poles in induction motor may be starting from 2 poles, 4 poles, 6 poles, even number poles only. Okay, and without pole, no induction motor never runs. 0 poles cannot be. Okay, cannot be 0 poles. It can be minimum number of poles for induction motor or any rotating machine will be 2 poles. Minimum number of poles is 2. So we can analyze. Let me write poles and NS. Okay, I am making a chart here. See, what is the condition to become induction motor? NS value. Your NS should be more than N, not this NS. Okay, induction motor NS. What is N given? 1440. You should get NS value more than that. Then only this becomes induction motor. So for that, see, now I am assuming maybe 2 poles like that. It may have 2 poles. Now calculate NS with having 2 poles. 120 into frequency 50 divided by number of poles 2. What is the speed you will get? You will get 3000 RPM. Okay. When it is 2 poles, what is the value of NS? 3000 RPM. So fine. Next you take 4 poles. When it is 4 poles, 120 into 50 divided by number of poles 4. So when it is 4 poles, we get 1500 RPM. So why can't be 6 pole? You can try that also. Okay, you can try that also. I am going to take now finally 6 pole. Okay, so 120 into frequency is 50 divided by number of poles 6. How much you will get? What is the answer? What is the answer? Very good, 1000 RPM. So 1000 rotations per minute. So can we stop here or can we go further? Yes, if you need, you can go further. You take 8 poles, calculate NS. But I recommend you to stop it here only. Because to check this condition first. See, NS value should be more than N. See, when it is 2 pole, what is your NS? Is more than N. NS is how much? 3000. 3000 is more than 1440. Yes, at 2 poles, it can become induction motor. Okay, this is selected. Okay. Next, check for 4 poles. What is the NS value you got? What is NS you got? 1500. What is N value? 1440. 1500 is more than 1440. Yes, this condition is valid. Okay, to become induction motor. So, yes, this poles can also be selected. Next, last one, 6 pole I have taken. So, what is NS value you got? 1000 RPM. What is N value? 1440. Is this condition satisfied? Say yes or no. Very good. No. Because NS value lesser than N. When NS is lesser than N, it cannot be induction motor. So this one 6 pole is ruled out. If 6 is ruled out, what could be 8 pole? It is obviously ruled out. Because you get speed much lesser than that. Okay, got it? So now you should give much more clarity. So 2 poles are possible. Either induction motor can have 2 poles or it can have 4 poles. Out of these 2 data, you have to give clear clarity whether you need to select exactly 4 poles or exactly 2 poles. For that, we have another condition called slip condition. Now I am calculating slip with these 2 speeds with respect to rotor speed. So now slip, what is slip formula? Ns minus N by Ns. So now I am calculating slip when Ns is 3000 RPM. So 3000 minus 1440 divided by 3000. So you will get a slip value approximately 0.2. I am not sure about this. So let me calculate this first. So 3000 minus 1440 divided by 3000. Yes, we are getting same value 52. But what is they are asking? Percentage slip. So multiply by into 100. Then how much you will get? 0.52 into 100. It become 52%. Is it good induction motor this slip? No. Okay, now check for 4 poles. See, for 4 poles, I am going to calculate slip here. So when NS is 1500, I am calculating the percentage slip. What is formula? NS minus N by NS multiply by 100. NS is 1500 minus N is 1440 divided by 1500 multiply by 100. Okay, this answer, how much we get? We can solve that. 1500 minus 1440, okay, divided by 1500. So I got answer 4%. Slip is how much? 4%. I got 4% of slip. Otherwise 0.04. Got it, guys? See, out of this two data, 2 poles or 4 poles, 4 pole is selected. Final answer is number of poles is how much? 4 poles. And what is the percentage slip? 4% or 0.04. So this one is ruled out. This one is ruled out. Why? Means slip is not within the given range to become good induction motor. See, for good induction motor, what is the range of slip? 1% to, very good, 1% to 5%. Your answer should come within this range. Got it? So we got 52%. No one will purchase machine with this slip. Okay. So customers are recommended to purchase induction motor. The slip should come within this range, 1% to 5%. Okay. Understood, guys? Then finally, see, slip condition not satisfied with 2 poles. With 4 poles, slip condition also satisfied. So both speed condition and slip condition, both are satisfied. So therefore, the selected number of poles is 4 and selected percentage slip is 0.04. Got it, guys? See, this type of problems are very important. So don't give up. Data is not given. If they are not given poles, how can we calculate the problem? Not be like that. They are checking, examiner, paper setter is checking whether students know this concept or not. Okay. Good induction motor, what is the condition? What is speed condition? Everything. So to check that, they could have asked this type of questions. Please pause the video and then copy down neatly. Okay, dear students, now we can solve another question. This question little bit different. Okay, we already done this type of problems from part 1 lectures itself, but slightly different. Okay, so mark this question as important for exam point of view. So VTU 6 marks. So let me read the question. A 3-phase induction motor. See, always you try to, once you are expert, you can solve the problem directly. Okay, so understand properly first. So how many poles are there? Induction motor. Okay, it is not working. Okay, induction motor. A 3-phase induction motor with 4 poles. 4 poles. This induction motor is supplied by an alternator having 6 poles and running at 1000 RPM. So this induction motor is getting supply from alternator. Induction motor supplied by an alternator having 6 pole and alternator runs at 1000 RPM. Okay, got it? This is the data. And they are asking, calculate synchronous speed. See, whatever they are asking, no calculations, all calculations related to induction motor only. So calculate synchronous speed. See, they didn't ask to calculate frequency of alternator. You must calculate, that's it. Because induction motor required electrical input. That is getting from the alternator, that's it. So ns, what is ns? And they are asking what is speed of the motor when slip is 4%. They are asking find n when s is 0.04. They are already given slip. When this slip, what is the speed? Okay, if I know ns and slip, I can easily calculate speed. Very good. Then last one is frequency of rotor EMF. They are asking what is rotor frequency? Okay, not for this slip, not for this slip. When induction motor running at 600 rpm. So what is the rotor frequency of EMF when speed is 600 rpm? Okay, at this slip it runs at some speed. Now they are asking what is Fr at motor runs at this speed. Got it? Understood? So this is a slightly different question. But need not to worry, we can solve because we already solved 7 problems. So we are very confident. So first calculate frequency as usual. Very good. PNS by 120. You are already told answer 50 Hz because data is like that. So P into NS, poles into NS divided by 120. Excellent. Okay, you done faster than me. Okay, frequency 50 Hz. Take this frequency here. Frequency 50 Hz. Later, you forget about whatever given in the alternative data. Forget everything. Concentrate only this side now onwards. So F is 50. Poles. Okay, calculate NS. By knowing frequency and poles, you can find NS. What is NS formula? 120 F by P. 120 into frequency 50. What is the number of poles? 4 poles. So what is the speed you get? Very good. 1500 RPM. So this is NS value. Solution for first question. Next is what is rotor speed? Now rotor speed formula is NS into 1 minus slip. They are asking what is speed when this slip. Okay. So therefore 1500 within the bracket 1 minus slip is how much? 0.04. So what is the answer you will get? 1440. Very good. Let me also check this one. 1 minus 0.04. Okay, excellent. Good. You are giving correct answers. Okay. So 1440 RPM. Over. Second question also over. Next is rotor frequency when induction motor runs at 600 RPM. So now third question is you can stick on to this formula Fr is equal to Sf. Now my intention is to find what is slip when this speed. Okay, when motor runs at this speed, what is the slip? So let me calculate. Slip formula is what? Very good. Ns minus n by ns. Okay. What is ns? 1500. Minus what is n? N is how much? 600. N is 600. See, at this speed, at 1440, this is the slip. But we don't know at this speed what will be the slip. If I know the slip, then only I can calculate rotor frequency. Okay. So divided by what is ns? 1500. Do it in calculator. How much you will get? You will get 0. Okay, 0.6. Very good. We got a slip value 0.6. Now calculate Fr. What is slip? Slip is 0.6 into what is the supply frequency? 50 Hz. Sorry. Okay, what is the answer? 50 into 0.6. 30 Hz. See, so far we got rotor frequency like very less value. 1 Hz, 1.5 Hz, 2 Hz, 2.3 Hz. But this time we got how much? 30 Hz. Why means rotor speed is very less with respect to synchronous speed. Okay, got it? Please pause the video and then copy down. Okay friends, next question number 9. This is little important, okay, because very easy question. So there is one mistake I wrote here, you have to identify. That is your job. A 3-phase 6-pole induction motor. Say induction motor. How many number of poles? 6 pole. Runs at 960 RPM. See, induction motor runs at 960 RPM on full load. And this induction motor, it is supplied from a 4-pole alternator. So that induction motor is supplied by 4-pole alternator running at 1500 RPM. So alternator runs at only one speed. That speed is ns. How much? 1500 RPM. And they are asking, calculate full load speed of the motor. See, how can you ask? This is the mistake. See, how can they ask full load speed? They are already given. Induction motor runs at 960 RPM on full load. How can the question will be like this? Calculate full load speed of the motor. What they should ask? They should ask full load slip. So please correct the question. Okay, instead of speed, they should ask what is full load slip. Got it? So they are asking what is slip. Okay, because the corresponding speed, this is full load speed, n suffix fl, full load speed. Then corresponding slip will be full load slip only. Okay, so what is required to calculate slip? To calculate slip, this is the formula, ns minus n by ns. So ns we don't know. What is n? 960 RPM divided by ns we don't know. Our intention is to find, our goal is to find what? Ns only. So ns to calculate ns of induction motor, what is needed? We need frequency of this data. That is found from this. So f is equal to pns by 120. So 4 into 1500 divided by 120. So again getting 50 Hz only. Okay, guys, please don't buy at that. Please calculate. Okay, there may be a question. You will get an answer 60 Hz. Like that also they can give the data. Okay, so you take the same frequency. Once copying this frequency towards induction motor side, f is equal to 50 Hz. Now forget about this data. Forget. Okay, concentrate only induction motor side. Now calculate ns. Ns of induction motor. 120 f by p. Okay, 120 f by p. What is supply frequency? 50 Hz. How many number of poles in induction motor? 6 pole. What students will do? No, without proper preparation, they will write alternator poles. Everything. You will get 0 marks. Okay, simple problem. You are going to lose marks. So that's why understand question properly. So how much you get? How much? Very good. 1000. Okay, excellent. Your answer is correct. 1000 RPM. Now take this ns, put it here. What is ns? 1000 RPM. Minus 960. What is ns? 1000 RPM. So do it in calculator. You will get an answer 0.04. Okay, 0.04. Numerator will be 40. 40 by 1000. You will get 0.04. So this will be the full load slip. So question is calculate full load slip of the motor. That is, we calculated it is 0.04. Okay, and don't stick on slip should get 1% to 5% only, 0.01 to 0.05 only. They can give data in such a way that you may get slip more than 0.05 also. Okay, that is the correct. That is also correct because data given like that. Okay, got it? Okay, guys, pause the video. Please copy down. Okay, friends, last problem of part 2 video. Okay, on induction motor problems. See, let me read the question. See, pause the video, copy down the question and try to solve without seeing the solution. You try to solve. After that, you play the video and see the solution. Got it? So, a 12 pole 50 Hz 3-phase induction motor runs at 485 RPM. What is the frequency of the rotor current? Direct question. Okay. Only one machine. Induction motor Okay, frequency is 50 hertz. Okay, number of poles is 12, and then motor runs at 485 RPM, rotations per minute, and they are asking what is FR. Okay, what is FR formula? FR is equal to SF. To calculate S, what is the formula? S is equal to Ns minus N by Ns. Then I need to calculate what? Ns I need to calculate. N is already given, 485. What is Ns? So Ns I will calculate here. Ns is equal to 120F by P. 120F by P. Frequency 50, poles 12. Use this data in that formula. So you will get 120 into 50 divided by 12. 12 1 ja, 12 10 ja. What is the answer? Very good. 500 RPM. So we got synchronous speed is how much? 500 RPM. Is it more than N? Yes, it is induction motor. Ns is more than N. Very good. Now take here. Take the speed here. Ns 500 divided by minus 485 divided by 500. Okay. You do it in calculator. Do it in calculator. You will get a split 0.0. How much? You already calculated? Please tell the answer. What is the answer? Okay, fine. 0203. Excellent. Okay, slip is 0.03. Now take the slip and put it here. Calculate FR. FR is equal to, what is the slip? 0.03. What is the supply frequency? 50 hertz. Okay, let me write neatly. So 50. 50 into 0.03, 5 3 is 15, 1.5 hertz. So rotor frequency is how much? 1.5 hertz. Guys, pause the video and then copy down neatly. See, there's 10 problems. In next part 3 video, I am going to do 3 problems only. Okay, and then one problem will be there, that is called special problem. That problem, see in module 4, there are 2 topics. One is 3-phase induction motor, another one is 3-phase alternator. Okay, they can ask question by combining motor and alternator. That is, I am going to call it as special problem. That problem I will be explaining once completion of alternator theory. Okay, got it? So in the next lecture, we are going to predict maximum 3 problems. Okay, so of different types. Okay, got it? So please share this content to your friends. Tell them to become member to this channel, so they can score out of 8 marks in the respective modules. First 3 modules completely video lectures are ready. Module 1, Module 2, Module 3. Go through the playlist, watch the lectures, make your own notes specifically for problems. Theory you can refer your college professor notes, okay, or your any other friends from other college, you can refer it. If I got means same material I am going to share in the WhatsApp group. So we have a WhatsApp group related to this channel. Okay, only members will going to be added in that group. So join to that group. We will do online classes for basic electrical laboratory to discuss around Viva questions. Okay, what are the predicted question come for exam in practical. So I am going to tell question as well as answers also. Along with that, I am planning to revise all the modules to all my members. Okay, what to study, where we need to concentrate more, all such things I am planning to do. And then with your support, definitely I can implement all my plans, 100%, there is no doubt. And then finally, I will provide solutions for model question papers, only problems. Okay, and for theory, I will provide video link. Okay, for that particular theory question, refer this video lecture. Like that, I am going to make it. And along with this, I will provide a question bank for university examination. Okay, to score out of out, what is the method we need to follow. To score just 35, what is the method we need to follow. All such things I am going to explain. Okay, please guys, don't hesitate to share the content. Please tell your friends. Okay, you and your friend together can score good marks. Okay, nothing will happen. your marks will going to deviate in the real-time exam. Whether your friend studies or not, you need not to bother. Okay, you just tell the good thing to your friend so they can watch it. Okay, got it? So if you study, you will get benefited, understand? He or she will get benefited. If not, you need not worry. But you done good job. You already told about the content available in the YouTube. So make utilize of that. Okay, do only such things. Whether they will do it or not, you need not to bother. Okay, have a nice day. Take care. Meet your next lecture. Problems for induction motor part 3. Very easy as well as conceptual problems. Okay, bye bye.